Hello everyone, in this video we will be learning series solution for homogeneous second order linear differential equation with variable coefficient. So सबसे पहले देख लेते हैं कि ये homogeneous equation किस form में होता है. So this is one of the form of homogeneous second order linear differential equation. That's how we can write it also. So I have written it here very first, which is given p0x d square y by dx square second order differentiation p1x dy by dx plus p2x into y which is equal to 0. यहाँ पे ये जो equation है इसमें p0x p0y sorry x p1 p2x, what is this? These are nothing but polynomials in powers of x, and p0 p1 p2 are nothing but the coefficients, variable coefficients. So in this whenever we get this kind of equation, the first thing is how to find the point, means at which point we have to find this series solution. That is first thing is there are two types of points like ordinary point and singular point at which we can find the series solution. So first of all that is important. So in this how we will decide the what is the point, depending on the solution we will follow. Here in this p0 x we will just keep x value as a and we will see what value we get it. If it gets other than 0 then it is ordinary point, and even after putting x is equal to a in this p0 x term, if we get the 0 value then it is a singular point. So series this solution gets applied to the ordinary point. So here this is the question which has been given, x is equal to a is ordinary point. As I said, it gets applied when it is ordinary point. So given equation is in this form, y double dash is minus xy is equal to 0. It will be easy to understand what is the method if you take one example and go through the whole process. So here we have to find the series solution at point x0 is equal to 0. Here it has been given the point. If in case sometimes they do not provide any point, so in that case also you have to consider the point x0 is equal to 0 and we have to start finding the solution. If in case it is not mentioned in the question, here it is mentioned, so it is better for us. So now let us start with solution. First of all given equation हमने consider लिख लिया यहाँ पे जो भी दिया था d square y by dx square minus xy which is equal to 0. Now this is second order linear differential equation with variable constants coefficients. So now for other thing this one, like as I said here, like this is one of the form of we can write the linear equation, linear homogeneous differential equation. This is one of the form. So we are the given equation we can compare with this equation so that we can find these values of p0x and p1 and p2x. So the given equation, if you I can write it here, this is d square y by dx square minus xy which is equal to 0. So whatever comes with this second order derivative, that is nothing but p0x. So यहाँ पे कुछ भी नहीं है, मतलब 1 है यहाँ पे. So p0x की वैल्यू हो गई 1, xy p1x which is nothing but dy by dx coefficient. In our given equation dy dx की term missing है तो उसका coefficient 0 हो जाएगा. That's why p1 of x will become 0. Now p2x is nothing but coefficient like जो भी y के साथ आता है उसका, that will be p2x. So here x is coming along with that in given equation, तो p2x की वैल्यू हमें पता चल गई उसके हिसाब से. Now at point x is equal to 0 हमें we have to find the series solution, because that's the point which they ask. We have to find the series solution at point that 0. So we are going to find, first of all we will check whether what kind of point it is. So I have kept 0 x value as 0 in this one in the P0 x value. So, that will be giving in this, if I will keep x value as 0, it is not going to change anyway, I will get 1 only. So, it is other than 0 if I am getting, if then it becomes ordinary point. Since I am getting here P0 of 0 value 1, so it is ordinary point. So, we will go ahead with the series solution here. So, now what we can do it, our equation 1 was nothing but the given equation, which is I have written here for your information. Now, here we have to assume the solution for it. So, let us that assumption is y is equal to series solution we are assuming, because we got the ordinary point around which we have to find the series solution of given equation. So, that assumption is y is equal to summation of n from n is from 0 to infinity a to the a n x raised to n. This is what our assumption is there. Now, we are going to differentiate this y with respect to x, so that I will get this next dy by dx. If I will differentiate this, then what will happen, this power will come over here. So, n into a to a n x raised to n minus 1, this n power is going to get reduced to n minus 1. Now, here you have to keep in mind this in the summation what happens as the n's power is getting reduced. यहाँ पे आप notice करोगे, यहाँ पे n की x की power n थी, यहाँ पे x की power n minus 1 हो चुकी है, तो x से वो reduce हो चुकी है. जैसे ही power x की reduce हो तो चले जाएगी, वो n का limit जो है वो x से बढ़ जाएगा. यहाँ पे n was equal to 0, यहाँ पे n की value 1 हो चुकी है. Similarly, now here this is I just simplified it further. I just took it out this bracket outside, nothing else. Now, similarly I will find d square y by dx square value as well by double differentiating. So, now further I am going to differentiate this one. तो ये क्या हो जाएगा, ये जो पावर n माइनस है 1 है x की, ये यहाँ पे आ जाएगी. तो what will happen, that will get multiplied. So, n into a ये यहाँ पे आ जाएगी, तो n into a n into n minus 1. तो यहाँ पे n a n as it is और ये n minus 1 मल्टीप्लाई हो जाएगा और x की पावर एक रिड्यूस हो जाएगी. सो इट विल बिकम n minus 2. सो यहाँ पे n minus 2 हो चुकी है. Now, keep it in mind again the same rule we by same way in the summation sign whenever we are doing this power, if n x की पावर x से कम हो गई तो ये n का जो लिमिट है x से यहाँ पे बढ़ गया. यहाँ पे n इज इक्वल टू 1 था, यहाँ पे नाउ इट बिकेम n इज इक्वल टू 2. सो कीप इट इन माइंड, x की पावर x से कम हो रही है, जैसे ही वो कम होती चली जा रही है तो समेशन n की लिमिटिंग वैल्यू दैट इज गेटिंग इंक्रीज. सो यहाँ पे ये पहले 0 थी, फिर 1 हो चुकी है, यहाँ पे n की वैल्यू 2 हो चुकी है. दैट इज दिस इज वेरी इंपॉर्टेंट to remember, because when we do this differentiation like in the summation sign, that's we have to keep it in mind. So इसके बाद हम देखते हैं कि हमें ये y की वैल्यू मिल चुकी है dy by dx d square y by dx square. So given equation जो है ये d square, इसके we can substitute the values in this equation 1. तो उसके बाद क्या हो जाएगा, जो भी हमें ये जो वाली डी स्क्वायर वाई बाई डी एक्स स्क्वायर जो आ चुकी है, वी कैन सब्स्टिट्यूट इन दिस इक्वेशन. देन वाई वैल्यू इज नथिंग बट आवर अजम्पशन, द इनिशियल व्हाट वी डिड फॉर वाई, दैट वी कैन कीप इट ओवर हियर. एक्स जो है वैसे ही आ जाएगा. सो दैट्स बाय डूइंग सब्स्टिट्यूशन आई विल गेट द इक्वेशन इन दिस फॉर्मेट. नाउ here now I can just expand this one, this x is outside the bracket, I just pull that inside it. Other than that I have kept all the terms as it is. यहाँ पे आप देख सकते हैं कि पहला जो टर्म है मैंने वैसे जैसे है वैसे ही रख दिया. यहाँ पे सिर्फ यहाँ पे x to the power n है, यहाँ पे x है, base is same, so index I can add the index or the power I can add up. So here it became x raised to n plus 1. Other than that everything I kept it as it is. Now यहाँ पे एक important चीज़ हमें याद रखनी है. Here we got the two different powers of x. लाइक यहाँ पे x टू द पावर n-2 एंड दिस इज़ x टू द पावर n+2। तो हमें क्या करना है, वो सारी पावर्स x टू द पावर n में कन्वर्ट करनी है, so that we can simplify it ahead. So that's the important thing which we have to do it. तो n की पावर यहाँ पे n-2 है, तो मुझे वो x टू द पावर n लानी है, मतलब 2 से मुझे वो उसको बढ़ाना है। तो now what I will do it, n power I will increase it. Now after this if you see here x की पावर यहाँ पे n-2 है, इन द सेकेंड टर्म x की पावर n+1 है। तो हमें करना क्या है कि बोथ द टर्म्स शुड बी इन द पावर ऑफ x रेज टू n, सेम पावर होनी चाहिए इन टर्म्स फॉर द बोथ द टर्म्स। सो व्हाट वी कैन डू इट, आई हैव रिटन दिस सेम इक्वेशन विच वी गॉट इन द प्रीवियस स्टेप हियर। तो यहाँ पे करना क्या है, हमें x ये जो है x रेज टू n-2 एंड x रेज टू n+1, ये दोनों को हमें x रेज टू n में लाना है, मतलब ये n-2 को x रेज टू n में लाना है, मतलब आई हैव टू ऐड 2 इन द n, सो wherever it is n I will be keeping n+2। तो ये जो टर्म है फर्स्ट टर्म, इंस्टेड ऑफ n it will become n+2 which is here, n-1 उसमें I will add 2 in that, so that's the reason it become n+1। n की जगह यहाँ पे an जो है सफिक्स, I will keep n+2, so I got here n+2, and इसके साथ हम in the index if I will add 2 here then it will become x raised to n. So this is how I converted this in the form of x raised to n. जैसे मैंने उसको I have increased that, I have made that power x raised to n, that limit also has changed it here, now it became x raised to 0, before it was x raised to 2, it became ये n की वैल्यू I have increased from n to n+2, जैसे 2 से मैंने बढ़ाई है तो लिमिट की वैल्यू 2 से कम हो चुकी है। यहाँ पे पहले ये 2 थी, n is equal to 2, now it became n is equal to 0 starting limit। So again I am repeating, x की पावर हमने 2 से बढ़ाई है यहाँ पे inside the summation sign, so that's a reason the summation, that limit value which is base limit for n, that reduced by 2, जो पहले 2 थी यहाँ पे ये 0 आ चुकी है। सेम वे वी विल गो हेड फॉर द सेकेंड टर्म ऑल्सो, यहाँ पे x रेज की पावर समेशन के अंदर n+1 है, हमें लाना है x रेज टू n में, तो x से उसे कम करना पड़ेगा, तो n की वैल्यू मैं x से रिड्यूस करूँगी, तो जहाँ पे भाई n है मैं आई विल रिड्यूस इट बाय 1, सो a n है यहाँ पे n, सो आई हैव केप्ट इट n-1, और इंडेक्स से भी मैंने एक को आई हैव सब्ट्रैक्टेड इट, रिड्यूस्ड इट, सो इट विल बिकम x रेज टू n। यहाँ पे मैंने रिड्यूस की है, inside the series I have reduced the power of x by 1, that's why in limit has increased by 1। तो पहले यहाँ पे जो था n is equal to 0 था, यहाँ पे n is equal to 1 हो चुका है। That point you have to keep it in mind very well, that happens with the series। Now we have to start both the series at same point of n, मतलब यहाँ पे जो सेकेंड टर्म है यहाँ पे सीरीज़ n इज़ इक्वल टू 1 से स्टार्ट हो रही है, यहाँ पे स्टार्टिंग पॉइंट फर्स्ट टर्म में स्टार्टिंग पॉइंट n इज़ इक्वल टू 0 है, तो दोनों का स्टार्टिंग पॉइंट सेम ही होना चाहिए। सो बेसिकली इफ़ वी कन्वर्ट, इफ़ यू यूज़ दिस फर्स्ट टर्म बिकॉज इट्स स्टार्टिंग फ्रॉम n इज़ इक्वल टू 0, सो इफ़ यू विल यूज़ दैट एंड यू विल एक्सपैंड दैट, then automatically this second word term will get covered into that। So that's why we will be starting putting n is equal to 0 in this first term and we will start expanding that. So if you will keep equal to 0, then this will become 2, this will become 1. Now here also we can do the same thing. Now this one I kept it as it is. Now simply by expansion of this term, then I will get here, I have taken here x to the power n common from this both the terms, from this and this term I have kept x to the power n outside, that has been taken outside, and here it is just simple multiplication I have done it. So rest of the things are same. Now what we have to do it, here x to the power 0 we got it, means we have the coefficient for x to the power 0, and here also we have a coefficient for x to the power of n, that we have to take it and we have to equate that to equal to 0. So, once we take the coefficient of x to the power 0 and equate to 0, यहाँ पे जो है in the previous slide, if you see this is the coefficient of x to the power 0 which I equated to 0. So, we will get a2's value, and x to the power n's coefficient means this whole thing I have to equate with 0. So, that also I have done it here. So, after equating x 0's coefficient I got a2's value, after equating x raised to n's with 0, then I will simply, I can just take this, I can rearrange this equation so that this whole term which is there in multiplication with this one, it will go in the denominator. So, I will get the value of a n plus 2. If you look carefully, this is a recurrence relationship, and which we can, recurrence means it is repeating again, recurrence relationship. So, in this we can keep different values of n, and we will find the different terms like a1, a2, a3, something like that, by changing the value of n. So, that would be my next thing. So, that recurrence relationship which I got it here, this relationship I will be using it to find the a1, a2 different terms I have to find. So, in this relationship I have put n is equal to 1, so that I got this value. Now, n is equal to 2, then I received the other value. This is a recurrence relationship which I have received here, that I can use it to find the different values like a1, a2, a3 and so on. So, I will be using it and I will be keeping that n's value. So, here I have written this equation which we received recurrence relationship relation. So, in this I will keep n's value is equal to 1. So, I will keep here, if I will keep one value, then I will get a3, then a0, then numerator and the denominator also I will keep n's value as 1. So, here we will get like 0. Same way then a3, this is the a3 value which we received it here, which is a0 upon 6. Now, here now in the second step what we will do is n's value is equal to 2. So, we will get here, if you will keep n's value 2, then you will get a4, then here it will be 2 a1 upon 3 into 3, here we will get 4. So, this is how a1 upon 12 we got it, this is nothing but a4's value. Now, we will go ahead with we will keep going on incrementing the n's value, so that further values we will get it. So, here a2 we got in the numerator, and we have found the a2's value. If you remember, we found already a2's value which was coming 0. So, we put it over here. So, a3 a5 became 0. Now, n's value 4. So, we got that as in terms of a3. a3 we already found it over here. So, a3 की value a0 by 6 मैंने यहाँ पे डाल दी है. Then after simplification I got a0 by 180. Now, these different values of all these terms, what we can do it in the assumed solution. If you remember, this was our assumed solution when we found that's a point, given point x0 equal to 0, that is ordinary point. After that we have did assumption like y is equal to summation of 0 to infinity and a n x raised to n. This assumption was there for this. In this is nothing but the series like a0 in terms of series form. How we can write it? Keep 1 to 0 1 2 3 n's value, we will keep going on, and we will, this is nothing but the series format. I have written it in terms of addition of summation of different terms. So, in this we will keep substituting the values of a2, a3, a4 whichever we found in the previous step. So, this will be the after substitution of the values in this equation, I will get the final answer as this one. So, this is nothing but the series solution of given equation, which was given in the format of d square y by dx square into minus x y. So, I just want to brief little bit. So, first of all we took the homogeneous second order differential equation in the form of p 0 x, p 1 x, p 2 x. Then compared with given equation, we found those values p 0 1 and p 0 2, p 0 values. Then we have checked what kind of point was that around which we have to find the series solution. Was it ordinary point or it is a singular point? Since it was ordinary point, we went with the power series method to go ahead and find the. So, we found the different values of p 0, p 1, and then we assumed the solution. After that, after assuming solution, we followed some expansion rules which are under series under summation sign, which we have to follow. After that, we just did the substitution like n is equal to 0, and we found the corresponding values of a 2, a 3 and different coefficient, and then finally we kept the values in the assumed solution, so that we will get the final series solution, final solution of the given series or given equation. So, these are all the steps. This is how we have to simplify or find the series solution for the given differential equation. Hope you understood all the steps clearly. If you go one by one, it will be quite easy to understand also. Thank you.